Hello, Mr. Linghorst here. We are going to start our work in Unit 5 by talking a little bit about the Industrial Revolution. Now, when you first hear the term revolution, a lot of people think war or a government takeover, but this is a different kind of revolution. We're talking about a revolution of ideas and essentially how people create things. So if we look at the official definition of the Industrial Revolution, it reads that factory machines are going to replace hand tools. So one of the most basic principles of the Industrial Revolution is that there's going to be a shift from things being made by hand and craftsmen to things that are being made by a factory. So when you think about just ordinary everyday things, your shoes, tools, clothing, those types of things, before the Industrial Revolution, those are essentially made by craftsmen. It takes a long period of time to make them. It takes a long time to train people how to make them. Now with the Industrial Revolution, we're going to start to see a change to things being made by a factory, which is essentially really how almost everything that we use today is created. And then the second part of the definition is also creating large-scale manufacturing that is going to replace farming as a main form of work. So there's also going to be this shift from our nation being largely a nation of farmers to there being more of a focus on working in non-agricultural type economic activities. So that's really what we're going to be talking about in this particular section of notes. It's really hard to pin down like a specific date. It's not really something you can date like a war starts at a certain time and ends at a certain time. This is kind of a gradual process, and to a certain extent, we're still experiencing that today. There's still things that we're doing today that are kind of an evolution, whether it be using more robots or 3D printing and things like that. Those are all parts of our modern day industrial revolution. Now, as we talk about the Industrial Revolution, the story is really going to need to start in England, all right? And we're going to talk a little bit about textiles, because that's the thing that really kind of kickstarts this Industrial Revolution movement. Textiles is another name for fabric. So if you go to Michael's or Hobby Lobby and you're going to buy fabric for a project, or you're going to make, an outfit or something like that, you're essentially buying textiles, or what we would call fabric today. Okay. Now, in England, they figured out a way to make textiles in a factory setting. So this is going to be much, much, much faster than someone creating it by hand on a loom. And England is very protective of this. It's very similar to what China did back when they had the secret of making silk. They did not want outside people to know this, because England, as long as they had a monopoly on this procedure, was able to make a lot of money and be really successful in it. So they didn't allow people that had a lot of knowledge about how these factories were built leave the country. They didn't allow people to export parts. But there is one way that we in America begin to industrialize ourselves, and that is because of Samuel Slater. Samuel Slater is an Englishman. He's working in the mills in England, and he decides to come to America, somewhat secretly, obviously, because they weren't allowed to just travel if they had this type of knowledge. And from scratch, in his mind, he creates the first textile mill in America in 1789, and was not a popular move by people in England. In fact, people from his hometown called him Slater the Trader. But he comes to America, sets up the first mill. This is a picture of what the mill looks like today. It's a historical location. People can go and tour it. Notice that it is by water. Water is going to be what is fueling the moving parts inside the mill. You can kind of see the mill race here a little bit. So there's going to be a wheel that's spinning, and everything inside is going to be hooked up to that wheel by a series of pulleys. So if you look at this diagram, for example, you've got the water wheel. This is going to be turning, and so all of these are attached. You can see the belts there, and all of these have parts on these different levels of the mill, and they're all going to be powered by this one spinning wheel. Okay, and it's going to be spinning by the power of falling water. Here's another picture of a cutaway. You can kind of see again the pulley system there. This is a picture of the inside of these mills. So very dangerous place to work. There's going to be a lot of moving parts. We're going to talk a little bit later about how children are used as factory labor, and is a very dangerous place to be. But this gives you kind of an idea of what the inside of one of these mills look like. One thing that does begin to change is the concept of how people view time. So we no longer have this get up when the sun comes up and go to bed when the sun goes down because you're a farmer and you only can basically work most of the stuff you need during daylight hours. If you'll notice, this talks about bells, it talks about scheduling. All right, this is really the beginning of the factory idea of time and working a time shift. This may also look very similar to a school schedule. So we do basically take the factory system and incorporate it in a modern school day. That's why we have bells and you guys go to various classes and those types of things. So the factory system is a term that describes the concept of bringing many workers and machines together to work under one roof. So instead of having a whole bunch of people on their individual farms, maybe creating fabric with a loom, now you're going to bring everybody to one place. It's going to be much more efficient. In many cases, you're even living next to the factory. They build dormitories and places where people can live right next to the factory. So it makes it faster and it makes it more efficient. This is the mill at Watkins Mill. This is about 20 miles north of us, up by kind of like Kearney, Excelsior Springs area. Very impressive mill. It's one of the best examples in the country of this type of textile mill that survives. And again, you can see this is Liberty. We're talking about Watkins Mill up here. Excelsior Springs is over here. Kearney's over here. So it's really like about a 15-minute drive, and it's an impressive facility. This is what it looks like inside. It's almost like you're going back in time into one of these textile factories. And we'll look at a couple pictures here. Again, you kind of get a feel for, how dangerous this place might have been with lots of moving parts. Again, like this is where you would take either the wool or the cotton, and then it's begins to get like processed and stuff. But look at the teeth on that, and then notice the wheel here, the pulley. All of this again is going to be powered by an external source on the outside. Here you see the pulley system again, and then notice it goes back here. This particular mill is actually powered by steam, which we'll talk a little bit later. There is a pond right outside, but that is for holding water that you need for steam. There's not actually a running like creek or stream or river that powers this particular mill. Another picture of the bobbins there. So a lot of these first factories that are built in the United States are built in the New England region. And there's really two reasons for this. One is just a geography situation. There's lots of fast-flowing rivers. It's easy to build these factories next to those rivers that are going to be able to generate power. So that's one reason. The second reason is there's a lot of people living in this part of the country. So you're talking about the most populated parts of the United States. So if you need workers, you've got the workers right there. So the fast-flowing rivers and then the availability to major cities are going to be two reasons why most of these are going to pop up in the New England region. This map shows in 1840 the number of spindles in operation, or basically textile factories. Notice the big purple dot here is like 500,000, 250,000 to 500,000, and like you see two of them up here. You do see some scattering in different parts down here, but like this is where most of the factories are going to be at the beginning of the Industrial Revolution. Now, about 1830 or so, things start to change. Instead of being located next to a fast-flowing river, people figure out that if you have this big container full of water and you heat it up to a certain point, it is going to expand and you're going to have steam, and then you can then generate basically like an engine off of the steam that's generated. The nice thing about this is now you can build your factory anywhere. You don't have to build it next to a fast-flowing river. You do need water because you're going to be heating up water for the mill and the steam power and stuff, but you don't need to have a fast-flowing river. So that's going to change in about 1830. Now, the next big concept of the Industrial Revolution is the idea of interchangeable parts. This is the concept of making an item out of parts that are going to be identical and can be mass-produced. The person that's generally given credit for this is Eli Whitney. There's a lot of kind of historical battles and who kind of really started this concept. But one great example from this time period is muskets or rifles, okay? So guns at this time period, all those parts, those metal parts inside the guns, were typically made individually by a craftsman or a blacksmith. So the problem is, if a part goes bad, you're going to have to then go to a blacksmith and create exactly the right part. And guns can be really tricky. You need to have all the parts in a gun to really fit well, and it can't kind of fit or it's going to backfire and stuff. Eli Whitney begins the concept of, okay, we're going to create a whole bunch of parts and we are going to make them interchangeable. So if I have a gun and my trigger breaks for some reason, I could take a trigger from another gun, or I could just, order that part. I'm not going to have to go to a blacksmith and have it specially made to a certain size and all that kind of stuff. So the concept of interchangeable parts, very important. We are going to talk about Eli Whitney a little bit in the next section as well, but he's generally the one given kind of credit for it. There's a famous example. He's trying to get a contract for um, making guns for the United States government. He brings a bunch of guns on a table to the United States Congress, and he demonstrates that you could plug parts from different guns into one, and it was all going to be easier to use and stuff. And it's kind of a famous legend. He kind of staged it a little bit, but basically he convinces the government to eventually buy 10,000 guns from him, and he demonstrates that he can do this by making interchangeable parts. It's faster. You don't have to have one person handcrafting each gun. So again, this is a car. These are all the parts in a car laid out. So if you go to the shop and you need a part, say it's a carburetor, you don't have to have a blacksmith in the back of the Toyota place, making a special carburetor for you and stuff. They just go to a part store and say, hey, I need part number 352B, and it's going to fit in your car, if that's the right part. So you don't have to make everything by hand. Much faster, much more efficient, and it's going to bring the price down in those as well. So we'll talk about Eli Whitney again a little bit later, but very important for the concept of interchangeable parts. So interchangeable parts have three major advantages. Number one, it's going to speed up production. So you can make a lot more of these. So for example, if you're going to make 10,000 guns for the United States government, you're going to want things to go as fast as possible so you can meet your deadlines, which he didn't. He was actually 8 years late in getting all the guns to the government. But it speeds up production if you have interchangeable parts. It also makes repairs much easier, as we just talked about. You can have one part repair another part on another gun. And then three, and this is important, it allowed the use of more unskilled labor for a lower salary. So let's use an example of shoes, okay? The way that somebody got skilled enough to be able to make shoes was to be an apprentice for a shoemaker. So if you remember, we talked a little bit about apprentices and indentured servants and stuff. So you would spend years and years and years learning from a master on how to make shoes. Then eventually you might get your own shop. It's going to cost quite a bit to pay you to be able to make shoes because you've invested like years of learning how to do that. You are an expert, all right? Once we have interchangeable parts, the thing that each person has to do is usually very specific. One person might be like, pouring the metal into a mold or something, and you're just going to learn how to do that and do that over and over and over and over again. It's efficient. They don't have to pay you as much because you haven't spent like 8 years in training to do it. So the whole change in using skilled or unskilled labor is going to be a very important aspect of interchangeable parts. All right, we're going to talk about a couple of inventors here. And if you dig into each of these guys, there's kind of like some like controversy with a lot of them on if they're the guy that officially invented this concept first or whatever. I'm just giving you kind of the generally accepted people that were responsible for some of these advancements. And we're going to start by talking a little bit about transportation. Robert Fulton is given credit for creating the first steamboat in 1803. This is going to be a huge advancement in transportation. It does look a little bit different than today's boats that you would typically see, like, on the Missouri River and stuff like that. His paddle is actually in the middle here. But this is a drawing of the boat called the Clermont, and there is a steam engine on there. The benefit, of course, is if you have a steam engine, you're not reliant on the weather, the wind, that kind of stuff. The bad side is they're very volatile. So it took them a long time to figure out exactly like what temperature things should be. Some people are burning different items to, create the steam and all that kind of stuff. So the steamboat's important. It's also very dangerous because a lot of them explode very early on. Second one is a communication invention. Samuel F.B. Morse invents the telegraph in 1844. This is going to dramatically speed up communication. So what happens is you have a device, and this would be hooked up with wires. You don't really see the wires here. And I'm going to tap out messages to somebody down the line. Somebody is going to need to be listening, and there's going to be two different types of sounds. One is a really like short, kind of like quick sound, and one is a little bit longer. So when you look at what we now call Morse code, named after the inventor here, if you wanted to do the letter A, you'd have a short and a long. If it was B, you'd have a long and then three shorts. If you do a distress signal and you do SOS, the reason why SOS is selected as a distress signal is it's easy to remember, it's easy to hear, dot, 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 long, 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 dot, dot, dot. So that's SOS. So when I was a kid, we had walkie-talkies, and there was like the Morse code key like this was on the back of like every walkie-talkie, because you would try and like send your friend messages using Morse code and stuff like that. But what happens is in real life when he invents the telegraph is it allows people in one city to be able to send a message very quickly to someone in another city. They use it for everything from the stock market to sending messages about family, whatever. But it's a super fast advancement as far as communication goes. When we get to the Civil War, we're going to talk a little bit about how Abraham Lincoln really utilizes the telegraph to be able to direct what's happening with his generals out in the battlefields. Lincoln was very innovative, very like cutting edge tech at the time, and he used the Morse code telegraph for lots of communications during the Civil War. Each of these has like a little video. I'm not going to play them on the screencast here, but if you go into the notes and you just go ahead and play, I did embed some videos that kind of give a little bit of a description on how each of these inventions work. All right, second invention, big time for agriculture, John Deere. Yes, this is the guy that John Deere, the company, is named after today. He invents a lightweight plow that's made out of steel. It's going to cut into the soil and turn it over. He invents this in 1836. So a lot of people say that John Deere invented the plow. He did not invent the plow, but he created this idea where his model or his version is going to like dig into the sod, into the ground, and then this is kind of like curved, so it's going to turn over the sod so you can then begin to work the soil easier. So he comes up with this idea to have the curvature, have this made out of steel. This side hooks up to a horse or oxen or some kind of animal, and then you, as the person that are running it, you pretty much hold on for dear life with these handles, but the ox or whatever you have is basically going to kind of go whatever direction they want to. And there's the video on the steel plow. All right, another agricultural one is Cyrus McCormick inventing the grain reaper in 1834. So up until Cyrus McCormick, if you went out and you wanted to harvest wheat, for example, these are some guys doing that. You've got this item in your hand that you're going, it's like a winnow, and you're going to like cut the grain, and then you have to kind of gather it together, and then you're going to have to thresh it and separate like the little grain part from the shaft and stuff. So this is how you'd like basically harvest grain before Cyrus McCormick. What he comes up with is this thing that hooks up to animals, and you write on it, and then this is going to cut and then collect the grain in kind of almost like a little kind of like compartment over here. So there's a video here that kind of describes that. I'll make sure it's sound. So then just have thing your cell revolution.